Today, I'd like to give you a comprehensive overview of Solaris and Houdini. Solaris is a toolkit that Houdini built in version 17 to provide support for USD. USD stands for Universal Scene Description, and this is an open source project started by Pixar. The idea is USD will make it easy for you to build very complex scenes with geometry, lighting, materials, cameras, etc., and share them between different systems. Houdini, Blender, DaVinci Resolve even now supports USD in 18.5. So right now I'm in the Solaris desktop inside Houdini. But to simplify things, I've created a custom desktop here where I've minimized all the parts of the screen that I won't be referring to. This will make it easier for me to make things much larger, so it'll be easier for you to see them on the screen. So we're going to cover how to create geometry or bring geometry into Solaris, how to set up lighting and control your lights, how to create a material and apply them, how to add cameras and position them, and then lastly, how to render everything. So it's going to be a soup to nuts demonstration of Solaris. First is notice on any of the panes where you can change the context is you want to change it to stage, because stage is the Solaris context. Now, stage is a USD term, and Houdini does a really great job of using USD terminology whenever possible when you're inside the stage context. That is, when you're inside Solaris. For geometry, there are two really useful nodes. There's SOP create, and then there's SOP import. You can either import a geometry from the object context, or what SOP create does is it provides a wrapper. It's kind of like a geometry node where if you go inside here, you can now use all the geometry nodes that you want to build your geometry here without having to change context. So I'm just going to rename this node geometry. And what I'd like to do is just make a sphere on top of a plane. So right now we're inside Solaris, and you can see in the network editor in the upper right it says Solaris. And the nodes inside Solaris are called LOPs. But if I double click this and go into SOP create, we're now, if you look in the upper right, we're now in the geometry context. So now we're working with SOPs, or surface operators. So let me just make a grid. And there we go. And next, let me make a sphere. There we go. I'll just use a primitive for the sphere. Let me merge them together. And there we go. And I'm going to take the sphere and just make it a little larger, twice the size, and let me move it up a bit. There we go. So we now have a sphere of radius 2 sitting on top of this plane. Now let's leave this geometry context and go up, and we're now back inside Solaris. A few things that I'd like to point out. One is in the viewer, you want to decide how you want the geometry and the scene to be rendered. You can use what's called Houdini GL, and this is a very fast, lightweight way to view your objects. So if you're not so much interested in lighting and texture, and you just want to lay things out, Houdini GL is a very fast way to do that. Storm is a renderer that Pixar made, and it's part of USD. So anyone that wants to use USD can use the Storm renderer. But we're going to use Karma. Karma is the renderer that Houdini built specially for Solaris. Now, there are two types of Karma. There's Karma CPU and Karma XPU. XPU uses both your GPU and CPU. Karma CPU just uses your CPU. Now, we want this to be fast, so I want to use Karma XPU. So how do we do that? I'm going to add a new LOP called Karma Render Settings, and select this. And if we look at the properties over here in the upper right, I'm going to change the rendering engine to XPU. Path tracing, I'll just go down to 8 to make things very, very fast. And for image output, I'm going to select filters, and I'm going to use a denoiser. And so here we now have a nice fast renderer that will display our viewport for us. Now, this is already a good time to talk about one important thing in Solaris. With geometry, the input in each node is geometry, and the output is geometry object. But in Solaris, the input in each node is a stage and the output is a stage. Or a better way to think about it, or a different way to think about it, is the input and output of each node is USD. And there's a nice shortcut too that Solaris provides, and that is you don't have to do merges. If you ever add another LOP, another node in line, Solaris assumes you just want to add something else to the stage. It makes things very clean and easy to work with. So we now have our geometry up here, and we have our renderer down here. The next thing I'd like to draw your attention to in the lower right is where I put the scene graph tree. Now, when you're in the Solaris desktop, the scene graph tree is right here in the lower left. The properties are in the upper right. The viewer is here in the upper left. And then you have the stage. The stage, I just wanted the stage to be very tall because in Solaris, your networks tend to be very tall. So let me return back to the custom desktop. Let's take a close look at the scene graph tree. Notice how everything is arranged in it's like a folder file layout. It's kind of like a file explorer on your computer, except instead of files and folders, you have primitives, or the building blocks of your USD scene, and containers for them. So right now we have geometry, mesh 0, and sphere 0. This is a good time to also introduce this idea that you can give a path to each object, be it geometry, cameras, material, etc. So let's go back inside the SOP create, and I'm going to do Control B to go full screen. What I'd like to do now is add an attribute to our two pieces of geometry. So I'm going to say create attribute or attribute create, put one here, and attribute create, and put one here. Now, Solaris supports a specific attribute called path. So I'm going to call this attribute path, select and change the class to primitives, and this will be a string. So this attribute, you can actually call it path or name, both of those work, but I like to use path. It's a good reminder that what you're doing is you're defining the path in your tree to get to this thing. In this point, we have the grid. Well, what's the path to that grid? Let's say we'd like /objects/ground. Now, if I exit full screen, look again at the scene graph tree. We now have the root up here, which is slash. We now have geometry, which leads us to sphere 0, and then we have objects, which leads us to ground. So what we could do is, let me leave all of these here. If I click on where we added the attribute for the grid, look what happens if instead of /objects/ground, what if I just did /ground? Now if you look at how the scene graph tree updates, under the root we have just ground, and then the sphere is still geometry sphere. Where did it get the word geometry? That's currently the node name. So if I change this to say node name, it updates the scene graph tree to where now we have node name and sphere 0. So let's come in here and let's add a path attribute to the sphere. We'll call the attribute name path, applying it to primitives, it's a string, and let's use ball. Now look what happened here. It took ball underneath node name. Now if we put a slash in front of it, it doesn't put it underneath node name, because that tells us it's like instead of just giving the file name, so to speak, and it building the path for you, we provided the absolute path. So what we could do now is have it to where all of our objects are underneath a common folder. So we could say /objects/ball. So we now have objects ball, and if we come back over to the grid, we could change this to /objects/ground. So now we have a container, or a component as it's called in USD. This kind over here lets you know this is a component. And we have a ball, which is a sphere primitive, and we have the ground, which is a mesh primitive. Okay, so there we have two geometric objects, and we've gone ahead and given them paths so that they're well organized in the scene graph tree. Next, let's do some materials. For materials, let me bring up the Houdini help page. If we scroll down and look at the documentation for Solaris, Let me click on using MaterialX in Solaris. Scroll down, there's two really important tips. The first one is because Karma XPU will never support the traditional VEX-based shaders used by Mantra and Karma CPU, MaterialX is probably the future of writing shaders for the Karma renderer. Very important. For this reason, I'm using MaterialX. MaterialX, by the way, is an open source project created by Lucasfilm and ILM. Just as Pixar created USD, Lucasfilm ILM created MaterialX. So let's come back here and we're going to start with making some materials. If you come down to the materials section, there's a few here that are most important. I will be using material library and material linker. Let's add a material library lop, and then let's add the material linker lop. So material library is where you build your materials, and the material linker is where you go through and assign which objects should be covered with which material. So these will be our materials, and this will be material linking. Okay, let's come in materials. If you hit tab now, there's a MaterialX section, and a very useful thing is the USD MaterialX subnet. So what I'm going to do is create one subnet for the ball and one for the grid. So let me just copy and paste that. So there we go. This will be the ball material, and this will be the ground material. Let's come into the ball, and by default it gives you a 5-node network. You have your inputs up here. We're not going to do anything with that. We have a section for the displacement map, and then we have the main shader. Now by default it uses MTLX surface. We're going to get rid of that, and the reason is if we return to the documentation and look at the second tip, Houdini's MaterialX support includes the MTLX standard surface node, a physically based Uber shader similar to the principal shader. You can use this node for most needs rather than defining your own shaders. This really is an all-purpose shader, and that's what I'm going to use. So I'm just going to start off standard surface, bring that in, and wire that up. So the first thing we're going to do is we're now building the ball material, and I'm just going to make it like a gold. Well, actually, first I'll just use a basic color, and then we'll add a material and use that. So if you select the standard surface, you have up here a bunch of tabs with a whole lot of features for customizing this material however you want. Let's say we want the ball to be red by default, and we'll come back up here. Now what we're going to do is select the material linking. Now we added 2 materials inside the material library. If you look again at the scene graph tree, you'll notice this every time we add a new lop and do something, this graph is going to be updated. That's because the input to the lops are USD and the outputs are USD. It went ahead and made a materials folder for us and added a ball and a ground. Materials, by the way, is the name of this node. We could say material name. Or is it the same as the name of the node? It's not. So it's just called materials. Is when you click on the node, if you come over here, it's the material path prefix. How do you want your materials to be organized? And right now it's saying any material you make inside there, prepend this path to it, meaning it's going to be in a kind of a folder called materials. We could change this to /material folder /, and now if you come down and look at the USD tree, you see we now have material folder with ball and ground underneath. So I'm just going to leave this as /materials / and there we go. I'm curious, what if we get rid of that trailing slash? What happens? That does not look nice. So it just prepended this string to the material name. So we do want that /. Okay, so now let's click on the material linker. Expand this, and we have 2 materials, ball and ground. If you select them, you can drag them over. And now on the right, we have geometry. Underneath objects, we have ball and ground. I'm going to take the ball, move that over, and the ground, and move that over here. We got an error because right now the ground material needs a little bit of work so that it'll work well with Karma XPU. Okay, so we did make the ball red, and we didn't do anything with the ground. So let's go back into the material library under the ground, and let's delete MTLX surface, and we're once again going to use the standard surface node, the all-purpose MaterialX shader. Let me move these up here. everything. Okay, now if I select this, I'm just going to make the ground, how about blue? There we go. So now we have 4 nodes in our Solaris or lot network. We created the geometry, we created 2 materials, and we linked them, and we updated the renderer. Now let's go in and use a little bit nicer material here. I'm going to go to the ball, and I'm going to make this gold. So I'm going to hit tab, and there's a node called MaterialX image. So this is how you can bring in your texture maps. In fact, I'll bring in, let's just start with one. Click File Name, and I have here a metal gold paint. I'm going to pick the color, and I'm going to take this and pipe it into base color. And now you can see it's kind of goldish. Okay, now if I go up and select ground, once again we have the standard surface which we made blue, but now I'm going to create an image, file name, and let's use cobblestone 19. Let me select the color, pipe that into the base color. Okay, there we go. Now it looks like maybe the UVs weren't well done there. So forgive me while I go back into the geometry, take our grid, and add UVs. In fact, I'll use the Labs Auto UV just to make this work very quickly. There we go. Now we come back up here. There. Now the cobblestone looks a little nicer. We get rid of the bottom grid. So there we go. We now have gold and cobblestone, and we'll return to the materials a little later on to just make it a little nicer. Oh heck, let's do it now. So I'm going to go back into the material. For the ground, I'm going to add a displacement shader. That way it won't look as planar. Also, cobblestone shouldn't be that specular, so I'm going to click Standard Surface, Specular, crank this down, give it a little flatter look. And now we're going to come up and use this displacement section. I'm going to bring in another image node, pipe it in, and I'm going to load the cobblestone displacement map and change this to vector. Okay, so we now have the displacement map, and by the looks of it, it's a little excessive. So I'm going to just dial that back. Instead of a scale of 1, let's use something like 0.1. Let's see, is it going to re-render? I have noticed the occasional caching issue. So I made a change, and for whatever reason, it's not re-rendering. So I'm going to come up here. I'm just going to maybe change from one node to another and see if that fixes it. It does. That does a better job of rendering. And so you can see the displacement is a little. There's definitely some displacement in the bottom. You can see the sphere now peeking out. So that's just a little more believable of a texture. Okay, so we now have 2 pieces of geometry, materials. Let's now look on lights. Now if you hit tab, come down to lights, there's a lot of presets, but there's also a nice generic one called light. And we're going to explore different types of lights and the light linker and the light mixer. So let's start with a distant light. Now, once we wire this in, you're going to notice things go dark. And that's because right now, Solaris is displaying everything using a nice kind of generic lighting for you. So you don't have to worry about seeing everything. But once you take control of lighting, you're now in control of lighting. So with that in mind, the kind of like the default standard lighting is now gone. Let's just take and rotate this a little bit. So you can now see it's coming in from this direction. This is a distant light, it's a directional light. So it's not where we place this light, it doesn't matter. It's more you just specify the direction it's coming in. And I'll do maybe a little bit of rotation that way. Now when you click on the light, look at the properties. For controlling the brightness of this, there's 2 dials, intensity and exposure. Intensity is linear and exposure is exponential. So think of exposure as a way to control lighting using the same language as f-stops, where if you go up a stop, you're doubling exposure. You go down a stop, you're, well, I might get in the direction right or wrong. Sorry about that. But with stops, going up and down a stop is the same thing as doubling or halving. So here, this is a pretty almost dim exposure. So rather than doing slight changes with intensity, we can double it. We can go up another one and double it again. It's a little hot. Let's go down. And then for fine tuning, you can adjust it with the intensity dial. There we go. So we've added our first light, and that's a distant light. Let's add a spotlight. Spotlight, there we go. Bring this in. Now the spotlight placement does matter. So one thing you can do is come up here, look through light, and say, let's look through the spotlight. If I lock my viewport to that, I can then quickly place this light wherever I want. Let's have it pointing right at the ball here. Okay, now I'm going to unlock, space G to return, and there we go. So here's the spotlight that I put up here. So if we click on the spotlight, we can once again increase the exposure, doubling each step along the way until it starts making an impact. Or what we could do is look through the spotlight, lock, and just get a little closer. That's another way to overcome the inverse square law. Unlock, space G, there we go. What if we do something crazy like 20? Okay, it is working. Now we just have to find a nice balance. 10 is a little high. 8, that's still dominating. 5. Okay, we'll leave it like that for now. And let's give this light a different color. Let's say we want this light to be red. So you now see the red tint that it applies to everything. So here we have 2 materials, 2 objects, and 2 lights. The next thing that we'll want to do is add a camera. So let's just take the render settings, bring it down, tab, camera, and bring this in. There we go. Now, like earlier we looked through the light, we can also look through the camera. So I want to come up here and look through cameras/camera 1. By the way, that once again reminds me we should revisit our scene graph, the USD layout, and see what it's done. So we've added 2 lights, and look, it created a folder called lights, and it added our 2 lights, distant light and spotlight. And it used the node names for the name of the light. So let's just make this one distant space light, and this one spotlight. There we go. It also created a kind of a folder, once again it's an X form, called cameras, and it put our first camera in there. Now that we have these 2 lights, what I'd like to show you is, I want to show you the light linker and the light mixer. Let's first add the light mixer. Mixer, there we go. Bring this in. By the way, you can now see what I mean about the LOP networks being very tall. Now with the mixer, let's just call this light mixer. And we're going to come up here and I'm going to collapse this and bring this over so you can get a nice good look at the light mixer. We only have 2 lights, but imagine if you had a dozen or more. It gives you a very nice interface for working with lots of lights. You can come up here, you can turn certain lights on and off, so you can see just how each one impacts things. You can also solo a light. The little star indicates solo, and this can allow you to mute a light. So if you want to see just what the spotlight does, you can solo it and see that, and unsolo it. But here's a common thing I like to do is grab all the lights and drag them over. You can now control the lights using sliders, using a table where you can quickly change the intensity, exposure, color, and color temperature. And you can also work with transforms. You can just expand this. Here's our 2 lights, and you can go in and translate it, rotate it, etc. I'm going to come to the sliders. Let's say we think we have too much red. So you could just grab the, by the way, the right is the exposure and the left is the intensity. So you'll want to keep in mind that the right is acting like f-stops, and that's why you have the little f in front here. Right now we're at f5. Here's f0, so we could say, let's start bringing down the red a little bit. And you can see how quickly Karma XPU is re-rendering the scene. We come all the way down here, and there's no red at all. Or we could go up much higher. Now here, once we've maxed this out, we can't go much higher. You could then always jump over to attributes. Spotlight, exposure is 6. You can just double click on this and type in a number if you are more of a keyboard person. Let me go back to 5, which is I think where we were at the beginning. I think 6 is a little happier. There we go. And then the direction light. The direction light here, we can change the color here at the bottom. You can come to attributes and change the color here, and I'll give this, like, let's say a slight yellowish color. There we go. A little interesting appearance. Let me bring back up the scene graph, and there we go. Let me bring this up. We now have quite a few outlines or little icons here representing the cameras and the lights and everything. Where's the camera? There's the camera. Let me bring this up. And I'm just going to relocate the camera for now. So we have different light icons, and we now have a camera icon. In the viewport, on the right-hand side, there's ways to hide certain things. Like here, you can display the light guides. If you want, you can hide that when you're no longer working with lights to have just a cleaner appearance. If you want, you can hide the cameras. The camera's still there. I think it's because we have it selected. There we go, yeah. So when you select the camera, it does bring it up. If I were to select the spotlight, it will appear even though we've hidden the light guides. So you can just select on the render settings at the end to get a nice clean appearance. So earlier we looked through the light. You can also come up here and look through the camera, do the thing where you lock, come around and specify or select the angle at which you would like to film things. And there you go. And then you can unlock space G to kind of reset. And there we go. So we now have, let's see, 1, 2, 3, 4, 5, 6, 7, 8 different nodes. One other thing I was going to mention was the light linker, tab linker. This LOP allows you to specify which objects are impacted by each light. By default, any light will interact with all the geometry, but let's say for this spotlight, what if we only wanted it to affect the sphere? So we're going to use it as an accent on the sphere. In that case, let's take the ball and bring it over. And now you can see there's a little red on the sphere, but not on the ground. Or if you mouse over this rule, this assignment rule, there's a red X in the upper right. You can get rid of that to return to default. And there we go. So we've now created geometries. We've created some materials and assigned the materials. So I like to have the material library contain all my materials and a material linker to assign materials to specific objects. We have 4 lighting nodes, a camera, which I'll call it ACAM, and then we have the Karma renderer settings. So if we wanted to actually render now, we would want to add a Karma renderer. Tab rendering, here is Karma. Let's add that here and pipe the settings in and select this. And now it'll redraw it for us. You can come up here and specify, do you want to render these as EXRs? Which camera would you like to use? What's the resolution and so forth? Also, which rendering engine do you want to use? We want XPU. So this gives you everything you need from beginning to end to create a static image. We didn't do any simulations or animation or anything like that, but this is a nice tall, typical looking LOP network inside Solaris. What I like to do, by the way, is select all these, come up to layout, and I like to align the nodes vertically. They already are. And then I like to distribute the nodes vertically so they're all evenly spaced. Thank you very much, and I'll see you in the future.